Hello, Chem 110. This video is the third in our series about molarity or concentration, and this video is about dilutions. So I have a little cartoon here to show you what happens in a dilution. So in a dilution, you have a large, usually amount of a stock solution. That's a higher concentration, and that's shown here. And then you take a small amount of it. So I've shown that with this little turquoise ball. Usually take that out with a pipette, and we call that little sample you take out of it the aliquot. We then take that aliquot and we put it inside a volumetric flask. And a volumetric flask is designed to measure just one volume, which is shown by a mark on the flask. So you put the aliquot in and then you fill up exactly to the mark with water. And so I'm showing two pictures here. The first imaginary picture is when you first put the aliquot in, and then of course, once you filled it with water, the solute that was in the aliquot disperses to make a new diluted solution, and diluted means it's less concentrated than the original. So we want to talk about how to calculate some things about this. So our first example is we have a stock solution, and we'll keep sodium as our solute, which we've been doing in the other videos, a stock solution with concentration of sodium, maybe from sodium chloride, maybe from something else, is equal to 0.100 molar. We take an aliquot of 2 milliliters, and we're going to dilute it to 100 milliliters. So that means our new volumetric flask will have a total volume of 100 milliliters. So the question is, what is the concentration of sodium in the new solution? Okay, so to solve this, you need to remember that when I ask what the concentration of sodium, and I can say, diluted, is it's the moles of sodium that were in the aliquot, which is just a word I like, rhymes with kumquat, over liters of the new solution. Okay, so the moles in the aliquot are, from the last video, you know how to do this. Well, we have 2 milliliters of the stock solution in the aliquot. We're going to need to change that to liters. And the stock solution that the aliquot was drawn from, again, we'll use molarity as a conversion factor. It was 0.1 molar, so that means 0.1 mole of sodium per liter of solution. So that's going to give us the moles of sodium that were in the aliquot. And then we need to divide it by, the total volume of. All right, so that is 0.100 liter, which is my 100 milliliters. So that gives us the concentration of sodium in the new solution is 0.00200 molar. Okay. Now, and so I do it this way just to really show you that the moles of sodium, which is here in the numerator, all comes from the aliquot. So that is our moles of sodium. The volume just comes from this mark. So if I tell you it's a 100 milliliter flask, then that's the volume of the solution. Now, there's something you can notice here, which can be handy if you're doing dilutions in this way, which is you can see how much you're reducing the concentration. So I'll just say note, an easy way to think about this is that we put a 2 milliliter aliquot which I'll just remind you comes from the stock, into a 100 milliliter solution. And we could reduce that to say that's a fraction of 1 over 50, or what we call a 50-fold dilution. So if we take 2 milliliters of stock and dilute it to 100 milliliters, we're diluting the stock by a factor of 50. So the concentration of sodium in the diluted solution is therefore going to be well, I should write it this way, the concentration of sodium from the stock solution divided by 50. And if you do that, you say, okay, well, it was 0.1 molar in the stock, and I divide that by 50, lo and behold, you get the same answer as above. So when you're doing a dilution, you can make a ratio of the milliliters of the aliquot over the total volume to get a dilution factor. And in case this isn't obvious, you could flip that. If you say 100 divided by 2 is 50, that is a 50-fold dilution. I just showed the fraction this way so you could see it. Okay, so that's a dilution. Often, if you're in the lab and you need to make a dilution, you want to answer a question more like this example. So we'll work with the same stock solution, but ask, how many milliliters of stock do you need to make, in this case, we'll say 150 milliliters of a solution where the concentration of sodium is now 0.0350 molar, and still using the stock that's 0.1 molar. Okay, so how many milliliters do I need? So I think it's helpful to think about this in 2 steps. So the first question I would ask is, well, how many moles of sodium do I need in my new solution? And, well, so my new solution is going to be 150 milliliters, or 0.150 liters, and I want to have it to have 0.0350 mole sodium per liter. And so, in fact, to do that, I need 0.00525 mole sodium. So this should look just like some calculations from the last video. So that's how many moles I need. And so then the second question is, well, how many milliliters of stock do I need to get that many moles? And I like to separate it out this way, at least in teaching it to you, because we have 2 different concentrations, and so it's helpful to keep them straight. So how many milliliters of stock do I need to get that 0.00525 moles of sodium? So this should look like another calculation from the last video. So, well, my starting point is I want 0.00525 moles of sodium. My stock solution is 0.1 molar, so it is 0.100 moles of sodium per liter of solution. And then I'm probably going to want to change that to milliliters. And when I do that, I find that I need 52.5 milliliters of the stock solution. Okay. So we'll go over another problem like this in class. I'm going to stop the video here because I think that's long enough. But this is 2 of the basic things that you want to do for dilutions. Calculate the concentration of a diluted solution. And we showed 2 ways to do that, by sort of longhand calculating out how many moles you need, and also by